Okay, today I'm going to present how to convert SolidWorks file for the ROS and Gazebo. Basically, what we want to do is to convert SolidWorks file into URDF format, which is understandable for ROS, Gazebo, and many other robotic applications. So, you can download any robotic file from the GrabCAD, and you can just download. So thanks to Nirav Joshi, I have downloaded this UR10 with movement, and I'm going to convert this file into URTF format. So let's just get started. Okay, file open, downloads, and then we have. So let's open the assembly file, resolved. Rebuild. Okay. Yes. Okay, let's just save it. Okay, so this is our UR robot. So the first thing is that we need to, this is a fixed point joint. Okay, and the problem with this one is that this origin and this origin is not same. So what, first of all, I want to make it float and then mate, and let's make it this one similar, and then press OK, close, and now I'm going to make it fix. So now this is fixed. So basically what we have to do is to convert this file for ROS and Gazebo, we need to define correct axis of motion and coordinates. So let's start. So let's go to the assembly and then reference and then pick a point. So we click on the face, center of face. So we click, it is automatically selected. Press OK, and then we call this P1. Now while this P1 is selected, I'm going to make an axis. This is just okay, let me make this P0 because this is starting point. Okay, so let me make this axis here, and then I will click over here. So this will be my axis. I'm gonna call this A0, and again I select P0 and then click coordinates, and it's gonna give me the coordinates over there, which z-axis is pointing not in the right direction, it is pointing towards my right. So what I'm gonna do is make it upward. Okay, so my z is pointing downward and I can always reverse the direction. So now it is correct. Let's just select it. Okay, I'm gonna call it C0, coordinates 0 for this. And the same thing we have to do for our motor. Let's select motor 1. So I'm going to hide that motor and put the coordinates here, like this. So the motor is hidden now. Okay, so first of all, let's just make it clear. Okay, so now I'm going to again put a point here, center of face, click OK, call this P1. Now while this point is selected, select axis 1 and point and face. So this is gonna be the axis. Click OK. Gonna call this A1 and again click on P1 and then put coordinates. Now you can see again the coordinates are not appropriate. Z is pointing, which is a blue arrow pointing this in this direction. So I'm gonna select this point and then press here. Now Z is pointing towards out of the plane, so now this is correct. I'll call this C1. Now let's just show it and then now hide this one. Now we're gonna put the repeat the procedure for this plane as well. Again, reference, point, center of the face. You can clear selection to make sure. Center, clear selection, center of the face. Okay, so I'm gonna call this P2, and while this point is selected, let's hit axis. This one is okay. Wanna call this A2, axis 2. Again, while this point is selected, hit this and then coordinates. Now you can see that the blue arrow, which is Z, is pointing inward, so we can always reverse the direction. And also I would like to make sure it is perfect. So now it seems okay. I'm gonna call this C2. Good. Now okay, now this joint and this link are connected. So what I'm gonna do is let's continue this one. I'm gonna hide this motor, which is motor 3. Okay. I'm gonna hide motor 4 and put the coordinates over here, because when we hit this motor, okay, so there is no rotation here, and also there is no rotation here. So what I'm gonna do is create the rotation between this point and this point. So I'm gonna hide this one, which is motor 4. Okay, yes, let's hide this one and put the coordinates here. Again, the procedure is same. Center of face, okay, and let's make this point P3. While this P3 is selected, hit axis and then this one, and this one is basically point and face plane. So call this A3, and now let's while select P3 and now hit coordinates. Now you can see the coordinates seems okay, but just make sure that they are good. Let's hit this place, and now oh yeah, you know, it's changed a little bit, so now it's much better. So let me call this C3. Okay, now this one is done. Now there is because there is a motion between this and this point, and again, okay, there is a motion between this and this joint, so I think we need to change a little bit. Yes, there is a motion between this point and this point, so let me call this P4 instead of P3. Rename P4. We call this A4 and C4. Basically, I forgot to put the dimensions between this motor and this motor. So okay, so let's just hide this motor Okay, so I'm gonna put the dimensions here, axes and coordinates, etc. So put at the center. Okay, and then I'm gonna call this point P3, and then as well this is selected, again hit this point. This is good. Call this A3, and now let's just select P3 point and now select coordinates. This seems okay. Now z-axis is pointing in this direction, it's the blue arrow, so I want this out of the plane like this. Now it's good. I'm gonna call this C3. I'm gonna pick all of them and place it and drag them here. Okay, so P3 here and C3 here. So this is my P3, this is my A3, and this is my coordinates. That is good. That seems okay. And this is my P4. So now this motion and this, there is no motion between this point, this link and this motor. So they are connected, motor 4 and this link are connected. So now we are going to convert motor 5. Okay, let's just hide motor 5. And now we are going to repeat the procedure here. Select point at the center of the face. Select OK. While this, let's call this P5. Now while this point is selected, hit axis and press this point and face. Okay, so let me call this A5. Now select point P5 and then hit reference and then coordinates. Now you can see Z, which is a blue arrow, is not in a appropriate direction, so let's just Z-axis and click here. Now this seems okay. Now we can see 5. Now we show this part and hide this part. So let's just rotate this. Okay, so again we have to put the points here like this. Let me call this P6. Put the axis. Seems okay. A6 and select point 6 and then hit coordinates and select Z-axis and hit OK. Now this seems good. Okay, and now we need to call this C6. Good. So now we have coordinate 6 here. Now we need to put the coordinates for the motor 7, so let's just hide it. So again the procedure is same, points and then call this P7. While this point is selected, hit axis. Okay, A7, and now again select point 7 and place coordinates there, and Z-axis is not in appropriate direction, so let's just hit it this way. So now it is good. Let's call this C7 again, and now we unhide it, and let's just drop this bracket, and now we have to repeat the procedure here. Let's just pick the point here. Okay, call this P8, and while this point is selected, put axis. Okay, seems good. Call this A8, and now put this coordinate system here. Okay, we need to select point P8 and now coordinate system, and then hit C, and then let's just hit over there. That's okay, that's good. So okay, C8. So now our basic procedure is complete. Now we have to export this file for the URDF. I assume that you have already downloaded and installed the add-in required for the URDF. So tools and export as URDF. Okay, so base link, I'm not gonna let anything decide automatic. C0, I'm gonna hit piece, and then M1 J1, this is gonna be coordinates 1, X is 1, continuous, and motor 1. Now I'm gonna select motor 2, joint 2, coordinates 2, X is number 2, continuous, and motor 2, and remember motor 2 and link 1 are connected. So let's just select this one as well and add this one, and okay, motor 3, joint 3, C3, A3, continuous, and let's just hit click motor 3, add one more link, click here, M4, J4, C4, A4, continuous, and again motor 4 and link 2 are connected. So that's good. Now let's repeat the procedure. M5, J5, C5, A5, continuous, and this one is motor 5. Add one more, M6, J6, C6, A6, continuous, and motor 6, and then add one, M7, J7, C7, A7, continuous, and then this one. Okay, this one is gonna be my bracket. I'm gonna continue this M8, J8, C8, A8, continuous, and this one is my bracket, and that is it. So once done, you can say this is okay, or you can preview and export. So first let's just save it, and preview and export. So the confirmation that this is correct, you can click on. So this is 0 0 minus 1, this is again 0 0 minus 1. There should be consistency. Again, 6, 7, and 8. So these should all be, because all our rotations are in along the z-axis. And okay, this is -1. You can always understand that there is a conventions. So there is one interesting fact. You should maybe try this one. Maybe it is good. So this one is J8. So let's give this some velocity here. Okay, these are the limits, so we don't want it to do anything over here. So let's just continue. Okay, press next. Check everything is good and export URDF and meshes, not on export URDF only. So now we are in the download. This is my UR screen too, and make sure that then you save it as not starting not with the small letters, otherwise sometimes ROS throws error. ROS causes problems, particularly when you are using move it. So UR screen 2 new. Okay, so I think it's done. Let's just check. So URDF file is here and it looks good. Now we shall go to the Ubuntu and run this file, and let's see what happens. So let's just copy this file somewhere where I can access it from Ubuntu as well. So see you in Ubuntu. Okay, now we are in Ubuntu and I have placed my file UR screen 3 in source in my ROS workspace here. So now let's just run it. Open in terminal. First we source it. Okay, now we're gonna build it. So I'm using catkin build. You can also use catkin make. It's a choice. Now I'm gonna go into that folder. And these are my files. So now we need to add the robot, and frame is the base frame. So now you can see his model, and let's just go closer. Now we can move all the joints. Joint 1, this is joint 2, this is joint 3, this is joint 4, this is joint 5, this is joint 6, this is joint 7, and I can show you the brackets as well. Okay, and here is the bracket. You can see it's also rotated. You can also do the same for Gazebo. Source, home, also one workspace, devel, setup.bash. Now I'm gonna run Gazebo. So you can see this is our robot UR10. Of course you can see it's reset the world. So we need to connect it with the global world. Anyways, we shall discuss this later. So that's all. Thank you very much for watching the video.